take a look at 1A. We classify by sides. Alex, what do you notice? All the sides are what? Good. Equilateral because all the sides are the same. Okay. If it's equilateral, it's automatically what? Good. These two go hand in hand. If all the sides are the same, that means all the angles are the same. Do not put acute. If it's equilateral, it's automatically equiangular. They're spelled very similar, they look very similar, they go hand in hand. If it's one, it's the other. They're always written together. Alright, questions over there? If we look at B, what do we notice about the sides of B? Courtney?
2 of them are the same.
Good. So if 2 of them are the same, we would call it what? Good, isosceles. So if we know 2 sides are the same, these 2 right here, the same measurement, then we know it's isosceles. What about the angles? What do you notice about the angles? Right? Oh, 2's. Why is it a 2's? Yeah, one big angle. Don't say acute. It's really tempting because these 2 are small little angles, but always look at all 3. Look at that third. The third one is bigger than 90, so we would say it's obtuse. What can we do for C that's going to be super helpful? Yeah, draw it. It's not there. Draw a picture. Draw it in. Later we have triangle A, B, C. We know the side AB is 8.5. We know the side BC is 7.2. And we know AC is 9.1. What do you notice about the sides? They're all different, so we would call it what? Baleen. When they're all different, we would say it is baleen. So the angles. Angle A is 35. Angle B is 78. Angle C is 67. What do you notice about all 3 angles? Yeah, they're all acute. So we say the triangle is also acute. All 3 angles are less than 90. So it's an acute triangle. Questions over that one? Okay. Give about a minute. Get started on number 2. Oh, and R is the vertex angle.
So I solve this triangle. That tells you need that information to help you solve it.
R is the vertex angle.
Again, try it out. Think about what it means to be an isosceles triangle. We're just talking about the sides. One is just throwing you off the one. Really, we're just looking at not necessarily either 1 or 2, but what do we know about isosceles triangles? Those are angles. That's what a triangle does, but we're going to go about both sides of an isosceles triangle. Different these things, what are you going to know about these 2? So you heard that plus there.
Fast, quick, and hurry. I have a question. I'll ask you in Spanish, okay?
This is what, first, I can look here, it's like, that looks good.
Actually, I forgot my question.
Well, solve this. You're on the right track.
And
Yep, keep solving, you're good. Give me a few more, again, attempt this. You're just watching up here, without trying it. Let's do that. Probably surprise yourself. All right. So 2 says find y and the length of each side of the isosceles triangle. Well, it tells you it's an isosceles triangle for one reason. What does it mean to be an isosceles triangle? Two sides are the same. The two sides that are holding up the vertex angle are the two sides. So what do I notice about this 5y? What do I know about the 5y? And then that 3 times quantity 2y minus 2. What do I know about their measures? They're the same. So I can say those are the same. We'll start learning later on about these base angles. If they're the same, that means it's an isosceles triangle. We'll go down the road with that later. But since I know they're the same, I'm going to set them equal like they're the same. So I'm going to say that 5y plus 6 is equal to 3 times the quantity of 2y minus 2. So minus 2. All right. What would be the next step in order to solve this? Distribute. I like that. Make it rain over here. There's nothing to combine over here, so I'm just going to copy that down for right now. 3 times 2 gives me a 6y. 3 times negative 2 is negative 6. Now I did all I could right there. Nothing else to combine on the same side, so I got to go across the equal sign. Move the smaller variable first. Be gone. So 6 is equal to y minus 6. Add 6. So I have 12 is equal to y. Found y, fantastic. Now what do I have to do? Or am I done? Find the length of the side, right? So what do I have to do with that, Sam? To find the length of the sides. Yeah, plug in the 12 or MC of y, right? Well, it says all sides, so if you notice up here, when I start plugging in, I've got a y right there, got one right there, got one all the way right here. So we're going to plug it into all of them. So I'll do the first one, SR. SR equals something, ST equals something, and then RT equals something. All right, well, let's figure out SR first. So Sam said we're going to take this 12 and plug it up there. So what is 5 times 12 plus 6? Again, all I'm doing is plugging these in here. 5 times 12 plus 6. Everyone's calculators out, ready to go. 5 times 12 plus 6 gives me a 66. So I know that SR is 66. Well, do the same thing down here with 8. I'm going to do 8 times 12. What's 8 times 12 give me? 8 times 12 gives me a, Justice? 96. And over here, quick, really fast, what's RT? 66, why? They're isosceles, they're the same. So I know if that's 66, the other side's going to be 66 as well. Again, you can plug it in there and figure out it will also be 66. All right. Questions on that? There it is. Give me a second on this one. Give me a minute on this one. Try the next one. Emphasis on try. Try it out.
And if you're wrong, it's not a big deal.
Erase it. Erase it.
You might actually be right. So take a look to find the measure of angle 1. Is it 1 on the inside of the triangle or on the outside of the triangle? Outside. So what do we know about angles on the outside of the triangle and the two angles that aren't touching it? What can we do with those two angles? Oh, yeah, you just add them together. So to find the measure of angle 1, because it's on the outside of the triangle, all you have to do is add the two inside ones together. Well, what's 58 plus 39? 97. There you go. There's a measure of angle 1. 97 degrees. Fill that in on your diagram. You find an angle, put it in your diagram. Right? Now let's move on. How can we find the measure of angle 2? What do you notice about these two angles right here? They're right next to each other. They fall on a straight line. So Gary, what do they add to? Perfect. We do 180 minus 97. What do we get for the measure of angle 2? What do we get? What do we do? 180 minus 97. What do you got?
Okay, everyone check the calculator out. Trying these out.
You like to plug in your calculator. What do you put? What do you get? 83. We know the measure of angle 2 is 83 degrees. Alright, fill it in. Right. How are we going to find the measure of angle 3? There's multiple ways. So we're not wrong.
More than one way.
A lot of these problems, there's more than one way.
Okay, I know.
Nigel, how are we going to find the measure of angle 3?
You add 83 and 25 together.
Yep. And then what are we going to do with those? Yeah. What is 83 plus 35? 118. And then we do 180 minus 118, and that gives you what? What's this one get? 62. Perfect. 62 degrees. Because all three angles of a triangle add up to what? 180. Well, if we're missing one of them, all you have to do is add the two other ones together, subtract that from 180. Another way, which would have been even less steps, we're going back to this outside angle. The outside angle equals these two angles added together. So you also could have done 97 minus 35, and you still would have gotten 62. And you're not wrong, it's just kind of how your brain works. There's different ways of getting the right answer, and that's okay, as long as you have the right answer. Watch it. Right. Give me a minute to get started on this. Really similar to this last one. Think about that outside angle.
Think about the angles. All we're doing is finding x. All right. You're still solving? Solve. We're just going to try to set it up right here. You ask yourself, are the angles on the inside or outside? So are all three angles on the inside, or is there one on the outside? One's on the outside. So just like we did, just like how you guys solved number 1 first, what'd you do to find number 1, measure angle 1?
97.
I got 97. How did I get 97? You got 97.
You add it together.
You add the two interior angles and set it equal to the outside angle. That's exactly what we're doing here. I'm taking these two angles and I'm adding them together. So I'm going to say this angle plus that angle equals the exterior angle. So I'm going to say 10x minus 10 plus 30 is equal to 12x minus 4. And again, it seems like it's a lot of work, but it's not, because they're always going to combine and simplify down. These are the ones that would combine together, so I'll have a 10x plus 20 is equal to 12x minus 4. No more combining I can do on either side, so I'm going to start moving the variables. The smaller one's the good one to move. And again, it doesn't matter. What do you want to stay positive? So 20 equals 2x minus 4. Add 4. Add 4. 24 is equal to 2x. Last step, that's an x by the way. 2x divided by 2 divided by 2. X equals, is that a 24? 12. X equals 12. Nice job. Do I need to find those angles? Nope. This says find x. Found it. Done. And I set those two outside angles, or excuse me, the two inside angles equal to the outside angle. Let's look at number 5. Number 5 is very similar to it. It's actually a little easier, so let's look at it. Are the angles on the inside or outside? One's on the outside, right? So that means when I've got one on the outside, I'm going to set it up like I just did. So I'm going to add those two inside angles. Something special happens here. These inside angles happen to be the same angle. He's going to figure out what they are. All right? So one angle is x. The other angle is x. And that's going to be equal to the outside angle. Some of you guys could recognize this right off the bat and solve it without really doing any work, realizing what it is. But still, if you don't know, set it up just like the one you did before. These two angles together equal the outside angle. These two angles together equal the outside angle. Well, let's do a quick little solve real quick. X plus x gives me a 2x is equal to 68. Last step, divide by 2. X equals 34. Real quick, easy stuff. Set it up exactly the same way. Are the angles on the outside? This is what you do. I wonder if there's a problem like if the angles are on the inside. Huh, weird. Not only that, pay attention to this, because a lot of people are forgetting about that. So just make sure you remember what that means. All right, give you about a second here and go.
Let's get it set up. All in together. Think about what all the angles of a triangle are.
Is it inside or outside? Okay, what does that mean? Just going to add up to 180. Yes, flip that equation. Usually they simple.
Alright, if we look at problem number 6, what do we know about all the angles inside of a triangle? What do they add up to? 180. So literally all you're going to do is take all three angles and add them together. So you're going to say x plus 37 plus x plus 67 plus, what does this box mean? It's 90 degrees. So you're going to say plus 90 equals 180. Whenever a problem like this, you just add all three angles together, set them equal to 180. then solve. So combine your like terms. What do we get when we do x plus x? What? Combine your numbers. What's 37 plus 67 plus 90? 194? Yep. And then you just solve. What do we have to do with 194? Move it over. We're going to subtract it. So then we get 2x is equal to what? 14. Divide by 2. X equals -7. Okay? Don't panic when you get a negative x like that. That sometimes is okay. As long as your segment or your angle's not negative, having a negative x value again is perfectly fine. Okay? What do the directions say? We found x. We also need to find what? Yeah, how are we going to do that? What do we have to do with the -7? No, plug it in. You're going to take -7, plug it in here. And what do we get when we do -7 plus 37? 30. We know this angle right there is 30. Take -7 and plug it in here. What do we get when we do -7 plus 67? 60. We know that angle right there is 60. Yeah, we know that corner one, we don't need to find it. It's 90 degrees.
Where's your sleepy?
Don't worry about that. Questions? Get all nuts and we go on it.
Boom. Let's go on to the proof now. All right, start right into it. Again, if you leave this blank, if you're not even trying, okay, because you have at least always right now you have 3, then you'll get more off the bat. Technically, you'll have 5 on this one if you start knowing the shortcuts. 5 off the bat without doing anything. It'll be 50% without knowing any of the work. So first thing you do is draw your little T-chart out. We got a statement right here. Reason right here. That's reason. 1, label your stuff. All right, let's go to the first thing. Everyone should have this reason as their number 1 reason. And that reason is? Given. So I'm going to go given with it. Given. There's 1 point. Nice job. Well, what was I given? E is the midpoint of AC and BD. What else?
Angle B.
Angle B is congruent to angle C. Oh, D for you. It's D for you guys. Don't worry about that. It's angle D. And then AB is congruent to CD, right? Those 3 things. Write them all down. So I'm going to write E is, I'm abbreviating, midpoint of AC and BD. All I do is copy down what's up there. Then I'm going to say that angle B is congruent to angle D. And then AB is congruent to CD. All that I was given, right? Write it right down. Whatever's given, that goes to your first statement. Again, all I'm doing is just copying this down. Whatever's right here, that's what I'm writing. Now, the 4th bit of information, or the 3rd bit, excuse me. What's the other thing I can get without doing any work? What am I going to know? And one more thing I can fill in this chart without doing any work yet. Seth? To prove. And what am I trying to prove? The triangles are congruent. I don't know where that's at, but I know it's somewhere down here at the bottom. So I'm just going to go ahead, write it down here, then I'll label it when I get to the end. ABC is congruent to triangle EBC.
ABE, not ABC.
That's what it is, yeah. I'm just reading what's up here. It's a little typo. So ABE is equal to ABC. Thank you. All right. Well, let's go and figure out what we know. Well, before we go there, if I have stuff that's given to me, I have to make sure I'm marking my picture. That's the only way to make sure we're doing this. I'm going to skip this midpoint thing for a second because that's going to be number 2, but I can mark this other stuff. B is congruent to D. So angle B is congruent to D. I'm going to go ahead and mark that. B and D are congruent. Their measures are the same. Also, AB is congruent to CD. Those are the same. Now what I need to do is I need to prove all the other pieces are congruent to one another. So I've done all I could right now. Now, let's start looking at our information that we're given here. E is the midpoint of AC and BD. What do I always do when I have a statement like this? What's going to be my reason now? What is going to be my reason if I'm given this statement? Definition of, in this case, definition of what? Definition of midpoint. Yeah, it's whatever that vocab word is. In this case, it's a midpoint. Now, what does it mean to be a midpoint? It's a point where? Yeah, real easy, in the middle. What do you know about each of those segments that's on either side of that point? They're congruent. So we're going to go ahead and mark those segments. So I'll start with BD first. I can say that segment is congruent to that segment. I also know it's the middle of AC. I know that this segment will be congruent to this segment. Now all we have to do is name those segments that are congruent to one another. I'm going to be nice and name the first one for you because that's how helpful I am. I'm going to say BE is congruent to what? So what segment is congruent to BE? DE. Let's go in order. We said BE outside in. The other one's going to be DE outside in. So it's going to be DE. Not only that, let's go to the other one too. There's going to be two here because I have two midpoints. So I'm going to call the other one AE. AE is going to be congruent to what other segment? C. Very good. And those are already marked. I'm just showing what I have marked. All right, getting there. Still don't have all the pieces marked. I've got all three sides of each triangle. That's good, but I've only got one angle. So we need to find these other angles. Let's go to step 3. What type of triangle pairs are these? And this is one of the freebies. Once I know I have this, this is always going to be one of the reasons. What type of triangle pair are these? What do they look like? Someone said it. Bow tie. What do bow tie triangles always have in them? Well, not necessarily. Good. What do I know? There's some sort of angle that bow ties always have. Chase? What's the chance? Chance. I said Chase Mother. Chance. What do you say? Vertical angles is correct. So anytime you have bow ties, always one of the reasons is going to be vertical angles. Vert angles congruent. Vertical angles are congruent. So I'm going to go ahead and mark that. Say, yep, that's congruent to that. Now he's got to name them. Let's go ahead. Who can name? I'll name the first one. So I'm a handy, nice guy. I'm going to say angle BEA is congruent to what other angle? What's BEA? Order matters. Go where it says. Going from red arc to green arc to no arc. So what's that in the other triangle, Gary? DEC. Very good. DEC. That was just naming those arcs. All right, good. Well, I've got three sides now. I have two angles. I got to figure out this third angle. Is there some sort of theorem out there that tells me about that third angle? That if I have two angles that are congruent, the third one's kind of a freebie? Hey? It is the third angle. You're the first one to get it all day, and I'm slowing down third angle. I'm saying theorem, the third angle. It is the third angle theorem. It tells me if I have two angles that are congruent in another triangle, then the third one is congruent true. 2. It's the third angle theorem. Third angle theorem. Well, we've got to name those third angles. Here's one. There's the other. Since they're in the corner, there's no intersecting lines right there, I can just call this angle A and angle C. Pull that right away. Now, look at my picture. This is why my picture is important. Are all of my pieces marked? Are all three angles marked congruent and all three sides? If you said yes and you're shaking your head, then I'm done. I can now say the triangles are congruent. What's going to be my reasoning to say the triangles are congruent? What tells me that all those pieces, those corresponding pieces of congruent triangles are congruent? It's that little saying to help you out. I told you that little saying. You remember that saying, that mnemonic device will help you remember how to write the letters for this. I don't believe that was the correct answer, but yes. Cool people count their coins, or crazy people cut their cats. However you want to think about it. But yes, that's your only reason. CPCTC. Corresponding parts of congruent triangles are congruent. That just tells me all the pieces are congruent. You're fine. There you go. All right. Last one. Give this a go. Hint. Draw a picture. Dap it up. Everyone draw a picture. If you do not have a picture drawn on your quiz, you're not trying. We tell you to draw a picture. Draw one, label it, you know they're congruent, now do it.
Wait, big on both sides?
Nope.
You don't have to.
I would do it individually to make your life easier. Okay? We have these two triangles congruent. If you haven't already started, draw the two triangles. So here's one triangle. Here's the other triangle. They're congruent, so their vertices match up. So I'm going to label this first one Q, R, S. So you have to make sure you label the other one in that same pattern. So Q is here, that means G has to go there. R is on the top, that means H has to be on the top. And S is over here, so that means J has to be over here. The vertices have to match up if they're congruent. Okay? After you drew your picture, fill in your information. It says RS is 12, I'm going to write 12. QR is 10, I'm going to write 10. And QS is 6, I'm going to write 6. The only information they gave you about this triangle is HJ. So I'm going to fill in that side with 2x minus 4. But we know these triangles are congruent. So what do you know about the corresponding sides? What about all the parts? They're also congruent. Okay, so if we look to find x, we have 2x minus 7. Which side is congruent to 2x minus 7? Which side's in the same spot in the other triangle? Oh. Okay, well if they're congruent, what can we do with 2x minus 4 and 12? Let them equal to each other. So because those sides are the same, you just make them the same. You set them equal. And you solve. So when we solve, what do we have to do with the 4? And we get 2x is equal to 16. And then what do we have to do with the 2? So x equals what? 8. All done. Do you need to find anything else? None of that?